Welcome back to the Deep Dive. Today, we're really tearing apart the architecture of modern TV distribution.
We are. We're focusing on that central brain, the piece that has to manage everything.
Exactly. It's that ultimate challenge, creating a seamless hybrid headend that can take free over-the-air signals and, package them.
And pipe them out instantly to both traditional cable systems and modern IP networks.
So let's name it. What is this central brain?
It's the Thor Broadcast H-16ATSC-IP-16QAM transmodulator.
That's a mouthful.
It is, but think of it as the master translator. It takes those raw ATSC RF streams, what you get from a standard antenna, and converts them
into QAM for cable.
Right, and it simultaneously generates IP streams for delivery across an internal network.
And the scale here is what's staggering to me. You aren't dealing with a simple two-channel box.
No, this single unit supports up to 16 separate ATSC frequencies.
So when you consider that capacity and the flexibility it buys you, that list price of $6,495 starts to make a lot more sense. It's serious consolidation.
It really is.
Okay, so let's talk translation. This is where the complexity usually hits, right? Merging all those streams without latency.
Yes, and this unit addresses that with, well, massive input flexibility and very precise control.
So you have the 16 ATSC tuners as the main input.
Correct. But it also accepts hundreds of IP streams and even has dedicated ASI feeds. It's built to take signals from really anywhere.
But what's the secret sauce? What guarantees that pristine signal quality once it's all merged?
There are two critical features here. The first is accurate PCR adjusting.
The program clock reference.
Exactly. That's what eliminates those tiny timing glitches that viewers hate. It guarantees perfect sync between the audio and video no matter how complex the conversion is.
Okay, and the second feature?
That's full control over PSISI editing. For system operators, this is a game changer.
So you're not just stuck with the channel information the broadcaster sends you?
Not at all. It means you can dynamically customize channel names, numbering, even the electronic program guide data for your own audience. You dictate what the viewer sees.
That's a huge operational advantage.
It is. And to back it all up, the RF output has a modulation error ratio, an MR, of 40 dBs or better. That means a clean signal and fewer expensive maintenance calls.
Right. So that brings us to the processing core, what we're calling the control room. Once the signal is in and cleaned up, we get to processing and security.
This is the real aha moment for anyone who wants control. Don't think of it as one converter.
How should we think of it?
Think of it as 16 tiny independent broadcast studios crammed into one box. It handles 16 groups of multiplexing, 16 groups of QAM modulation, and 16 groups of scrambling.
All at the same time?
All simultaneously.
That scrambling capability sounds serious. How critical is that for, say, a managed campus network or a hospital?
Oh, it's highly critical. The unit supports up to 4 simul-script conditional access systems, and it's compliant with the big ETSI standards.
Meaning it's compatible with pretty much every major system out there.
That's the strategic value. You get integrated security and compatibility without needing a bunch of external hardware.
And all that power doesn't require a dedicated team to run it, thankfully.
No, it's all managed remotely. A simple web NMS interface. And you can push updates through the web, too.
And physically, it's a compact, lightweight, single-rack unit. It even ships TAA compliant with a 2-year warranty.
So what this all means for you, the operator, is that this box isn't just merging streams. It's a central point for managing and securing how live, free content gets distributed.
Across both IP networks and traditional QAM systems.
At the same time, it gives you total control over branding, timing, and importantly, access.
So that leaves us with a final thought to mull over. Given this flexibility to handle so many input formats, ATSC, IP, ASI, and output formats, and to manage all the data and scrambling on the fly, what future applications could arise from this? I mean, in areas like, say, targeted local advertising or even emergency broadcast overrides. Something to think about as the broadcast world keeps evolving.